after Newton worked on his first three laws of motion, he was then quarantined back at his house because the plague was moving through London. So his family owned an orchard. So Isaac Newton was spending a lot of time, oh, he got his hair, spending a lot of time watching things fall. And as he watched the apples fall out of the sky, his big leap was that the force that pulls the apple out of the sky is the same one that holds the moon in space. So, yes, that's a piece of green cheese. Holding the moon up there. So then he called that force gravity, and gravity, his law of gravity says all objects that have mass are attracted to each other. And they're related like so. So as force of gravity went, well, you have mass 1 and then you have mass 2. They have to act on each other. It's proportional to the distance between their centers. And then that number doesn't come out right, but the relation does. So we need some constant of proportionality. This is called the universal gravitational constant. With this big swoop, he takes what is the Aptol's constant and makes them the moon. He either elevates the status of everyday objects to celestial objects or takes the celestial objects and make them everyday. Either way, it's pretty exciting. He never found out what his universal gravitational constant was. It took a guy named Cavendish to figure it out. 6.67 times 10 to the negative 11th newtons per meter squared, kilogram squared. Don't worry about the funky units. It's just to make all of this turn into a newton. So now, let's do some math with it. We need to find two objects that have mass. I like. Here's me, Mr. Lubbs. I have a mass of about 70 kilograms, and then about 1.5 meters away is a beautiful cheeseburger. And on that cheeseburger is cheese, because I like cheese. You can almost see that. And some burger. And let's throw some bacon in there just to make it nice. There we go. Now this bacon cheeseburger is 1/2 kilogram in mass. Oh, it's a big one. So, what's the force of attraction between us? Well, we have big G. We have the mass of Mr. Lubbs, the mass of the cheeseburger, and then the distance between us squared. Let's plug that in. 6.67 times 10 to the negative 11th times the mass of Mr. Lubbs, which is 70 kilograms, times the mass of the cheeseburger, which is 1/2 kilogram, divided by the distance between us, which is 1.5 meters. All right, take that, and we're going to square it. And as we multiply it all out, what we end up getting is 2.3 times 10 to the negative 11th newtons. That's not very big. I thought the attraction between us was greater. So, what does this mean? Well, G is so small that you need something the size of a planet. So with that, let's find the attraction between something else. Where did my Earth go? There it is. Oh, I like this planet. So now, let's take the Earth and let's find out how hard it pulls on my cheeseburger. So, here's the Earth. Here's my cheeseburger. Well, let's make it smaller, quicker. So, what is the mass of the Earth? Well, if you remember, it's 6 helograms. Oh, you'll never ever forget that now. However, technically, it's 5.98 times 10 to the 24th kilograms. So what's the, and let's see, what's the radius of the Earth? Well, all right, so force of gravity between them, we have big G, mass of the Earth times the mass of the cheeseburger divided by the distance between them squared. But in this case, the Earth is so large, all right, so that we really, all we need is the radius of the Earth. We're going to take that and we're going to square it. So let's plug some numbers in now. 6.67 times 10 to the negative 11th. Mass of the Earth is 5.98 times 10 to the 24th kilograms. My cheeseburger is half a kilogram divided by the distance between us, which is the radius of the Earth. Ooh, radius of the Earth. Radius of the Earth, if you look on the front of your book, which is, where's the front of my book? I'm finding it around somewhere. 6.4 times 10 to the 6th meters. So 6.4 times 10 to the 6 meters. Take that and square it. Do a little bit of algebra. What you end up with is 0.49 times 10 to the 1st, which is 4.9 newtons. This is the force of gravity on my cheeseburger. The force of gravity is also known as the weight. Weight is measured in newtons because it's the force of gravity. Well, let's take a look at this. So we have a force on my cheeseburger pulling it down. What do we know from Newton's second law? From Newton's second law, let's get a little better one. F equals ma. But what force is it? It's the force of gravity. So I want to know what the force on my cheeseburger. So the force on my cheeseburger is ma, and that's the force of gravity. Is the acceleration of the cheeseburger. Big G, mass of the Earth, mass of the cheeseburger divided by the radius of the Earth squared. Mass of the cheeseburger drops out. The acceleration of my cheeseburger when I drop it is big G, mass of the Earth divided by the radius of the Earth squared. I already know what the acceleration is when I drop things. It's G.